So first question is find the configuration of copper ion. We know that copper metal has 3d10 4s1. So the copper 2 ion will simply be 3d9. So it will be 3s2, 3p6, 3d9, and that's it, because 4s1 and 3d10th electron is gone. Okay, next one, copper hexa aqua copper 2 complex. This is blue, but it's a good idea to write pale blue. Okay, not just blue. आप खाली ब्लू भी लिख दोगे तो मार्क्स तो मिल जाए. और इसकी शेप ऑक्टाहेड्रल है. कॉपर टेट्राक्लोराइड या टेट्राक्लोरो कॉपर 2 आयन या कॉम्प्लेक्स. सो इसका कलर येलो होता है. अगेन अ कलर यू आर सपोज्ड टू रिमेंबर. कॉपर कोबाल्ट इनके आपको याद करने हैं. And it has a tetrahedral shape. Okay, octahedral complexes of copper 2 with different ligands can have different colors. Explain why. So again, where do colors come from? They come from the change in energy, the gap in energy that they have. And those gaps correspond to different frequencies of colors that are absorbed. ठीक है? We don't have to talk a lot about कि ligand आता है वो between the axis, along the axis करता है. All of that simply tells me कि जो excited electron है उसकी energy vary कर रही है. And that's what we have to talk about. That for different ligands, the gap in energy that's going to form is going to be different. So different frequency of light will be needed to be absorbed. So and okay, so I don't think I need to write it. समझ आ गया ना?
Yes, sir.
Copper 1 and silver 1 salts are colorless. Explain why. Again, copper 1 and silver 1. Silver 1 अगर आपको नहीं भी आता, copper 1 के बारे में तो आपको पता है that copper 1 is 3d10 because 3d10 4s1 is copper. So copper 1 is 4s1 lost, so it's 3d10. So that means that D subshell is complete. तो अब कोई भी इलेक्ट्रॉन D में प्रोमोट नहीं हो सकता. D में वो जंप करके एक्साइट करके नहीं आ सकता. अगर उसने आना है तो इट हैज टू गो इन सम अदर सब शेल और सम अदर शेल जिसके लिए एनर्जी उसको जो चाहिए वो विजिबल लाइट में होती नहीं है. ठीक है. सो विल सिंपली से दैट दे बोथ हैव कंप्लीट डी सब शेल, सो नो इलेक्ट्रॉन कैन be excited using visible light to a higher orbital. But let's see. Consider the following two equilibria and associated data values at 298 Kelvin. ठीक है, equilibria उसने दे दिया और case tab भी दे दिया. So what's happening is you have AgBr solid, which is ionizing and forming Ag and Br minus ions. ठीक है. And the silver and ammonia, they are forming a complex. Okay. The equilibrium constant for equilibrium 1 is the solubility product Ksp of AgBr. ठीक है. The equilibrium constant for that is the Ks tab. Calculate the solubility at this. So solubility is from the equilibria, but we can still solve it. हमें आना चाहिए. So let's see. So the solubility is going to be, I have the Ksp, and Ksp is what? It is the concentration of silver ion and the concentration of bromide ion, right? So that's going to be x times x squared is equal to 5 into 10 power minus 13. Take the square root and there you go. We will be able to figure this out. ठीक हो गया? Okay, so just remember the units are going to be, in this case, moles per dm cube, because हमारे पास ये Ksp is in mole square dm minus 6. Use Le Chatelier's principle as applied to equilibrium 1 and 2 to suggest why AgBr dissolves in concentrated ammonia. So if I add ammonia to AgBr, so what's going to happen? क्या होगा? इस इक्वेशन को देखें. अमोनिया की कॉन्सेंट्रेशन बढ़ रही है. When it increases, it goes forward. So more of the complex is made, and this is going to be reduced because अगर ये बढ़ रहा है तो इसको कम करने के लिए वो इधर को जाएगा, तो ये यूज अप हो जाएगा. And when this is reduced, the equilibrium is going to shift forward to increase it. So more silver ion is going to be made, and that is going to be used to make more of the complex. right? So that is why we know that when concentration of ammonia increases, equilibrium shifts. So equilibrium 2 shifts to the right. ठीक है? और इसका impact क्या है? इसका impact है कि silver ions concentration will decrease, which is going to impact this equilibrium. So the silver ion concentration decreases. So equilibrium 1 shifts right again. और उसका मतलब ये कि वो solid dissolve हो जाएगा. Use equilibrium 1 and 2 to construct the equation for reaction of this with concentrated. तो बहुत आसान है. Basically, you just have to add both of these together. क्योंकि इससे ये बन रहे हैं और ये बन रहा है. ठीक है, तो ये पहले इधर से ये दोनों बनाता है, ये अमोनिया के साथ रिएक्ट करके ये बनाता है, और ब्रोमाइड वहीं का वहीं रह जाता है. So we are going to start with AgBr. We are going to add ammonia to this. It's going to form Ag plus with two ammonia था ना, linear है, and bromide ion. Let me see. Yeah, that's it. Write an expression for the equilibrium constant of equilibrium 3. Acha. KSP is a product. K stab is a product. So their constants of mixture will also be a product. And that product is this. तो हमारे पास ये चीज है जिसका K stab है ये, और हमारे पास ये चीज है जिसका K है ये. Now this thing is already used over here. So that means you're just left with this one and this one. इसका ये है और दूसरे का ये है, इन दोनों को हम मल्टीप्लाई करते हैं, because that's the only thing that we have. AgNO3 AgNH3 का इक्विलिब्रियम क्या है? It is K stab. ठीक है? If you don't understand that, then let's try to write it out. So हम इसको लिखने की कोशिश करते हैं. This over what was this one? Ag and ammonia. ठीक है? So Ag plus and ammonia squared times वो दूसरे वाला ब्रोमाइड वाला लिखते हैं जरा. Bromide 1 was Ag plus की concentration times bromide की concentration divided by AgBr की concentration. And do you notice that the extra ones are going to be cancelled out? This one and this one cancel out. And what are you left with? You're left with this. You're left with this. And this. सोचो, अगर हम डायरेक्ट सिर्फ इसी इक्विलिब्रियम को लिखते तो हम क्या लिखते? हम लिखते AgNH3 2 प्लस की कॉन्सेंट्रेशन टाइम्स Br माइनस की कॉन्सेंट्रेशन divided by AgBr concentration and ammonia concentration squared. How is that different from this thing? Yes?
Sir, हम solids की concentration नहीं डालते थे कि like डालते थे?
No, in an equilibrium, if you have a solid, it's going to be there because it's taking part in the equilibrium process.
Oh, अच्छा अच्छा. So the second one जो हम नीचे है वो वाली हम लिख सकते हैं?
क्या मतलब नीचे वाली लिख सकते हैं?
Like एक तो वो ऊपर वाली right और एक नीचे वाली
This
like
one?
हम जो equilibrium 3 की सिर्फ लिखी है.
Yeah.
So can we just simply write that?
Yeah, we can. But notice that this whole thing is the same as this whole thing. What's different? Ag plus वो cancel हो जाएगा तो यही बन जाएगा. So that simply tells me that this is nothing but the K stab multiplied with KSP. Now back to your question कि हम solids को ignore क्यों करते हैं? It's the same question as हम water को ignore क्यों करते हैं? If a solid is extremely insoluble, then it's going to have a very, very high concentration in the denominator, which will destroy the whole value that we're going to have. हम उसकी nonces को appreciate नहीं कर पाएंगे. And that is why we ignore it. And then whenever we ignore it, we give it a new name. लाइक के ए में हम जब के में वाटर को इग्नोर करते हैं हम उसको के ए बोलते हैं. जब हम आयनाइजेशन जब हम ट्रांसफर मेटल में उसको इग्नोर करते हैं हम उसको के स्टैब बोलते हैं. सो अगर हम यहाँ पे भी सॉलिड को इग्नोर करेंगे हम उसको कोई नाम देंगे जैसे के एस पी, राइट. बट ओवर हियर वी हैवंट गिवन इट अ नेम, we haven't called it something else, like this is just k of equilibrium 3, so that's why we can't ignore it. So now we'll just multiply this and we will get our answer. I really like this question. Explain why transition elements can form complex ions. Really simple, they have d orbitals available और उसकी वजह से the ligands can make dative bonds with them. So transition metal ions or transition ions have d orbitals available to make dative bond. Complete table to show the coordination number. Coordination number is the total number of dative bonds made by the central ion. And the shapes and overall polarities. Okay. Square planar है तो clearly 4 है coordination number because 4 उसने bonds बनाई होंगी. And polar or non-polar. So it has En and it has chlorine. It will definitely be polar. Confirm, because chlorine na bhi ho, nitrogen has a very high electronegativity. So this will be polar. Silver with 2 ammonia. This is non-polar because linear structure hai. Dono sides se wo cancel kar denge dipoles ko. Even though it's polar on either side, the bonds are polar, but the overall structure is non-polar. So the coordination number is 2 because it's bonded to 2 dative bonds. And then we have Fe with 2 OX, 3 OX. So ye octahedral shape hai because there is each of these is a bidentate ligand. So it's going to have 6 coordination bonds. And 6 is actually a hint for us to figure out ki octahedral hoga. And the structure will be, yeah, non-polar hoga. Define K stab. So K stab kya hai? It is the equilibrium constant when a complex is formed. Okay. So it is the equilibrium constant for when a complex ion is made in a solvent. Yeah, in a solution. Okay. This one, we have 2 equilibriums we want to figure out. Construct an expression for the solubility constant K stab for equilibrium 1. Okay, so we have the nickel. So nickel with 3En 2 plus iski concentration divided by En concentration cubed and nickel with hexa aqua iski concentration. Okay, so this is a ligand exchange process and we have written this. Iske units kya honge? Mole per dm cube, mole per dm cube. So this will cancel out. So you have 1 over mole per dm cubed. So mole minus 3 dm plus 9. Because 1 over mole per dm cubed there. Describe what the K star values indicate about the position of equilibrium for equilibrium 1. Let's look at these. And use the K star value to deduce which complex is more stable. Again, the K star value for the equilibrium 1 is much higher than the K star value for the second one. So it tells me that the first one is more stable. Okay, that's what. So again, what does a high value mean in terms of equilibrium? इसका simply मतलब ये होता है कि equilibrium is more towards the right than this one. So अगर ये right की तरफ जा रहा है तो ये कम उतना ज़्यादा जा रहा है क्योंकि उसकी values में काफ़ी ज़्यादा फर्क है. ठीक है? So we'll simply say that position of equilibrium 1 and 2 is more towards the right and the first one is more stable. अगर ये value less than 1 होती ना तो हमें पता लगता है कि वो left की तरफ ज़्यादा है. Explain why transition elements have variable oxidation state. That is because they have why do they have Why do they have variable oxygen state? They can have more than one stable ion within complete these subshells. I think that should be the answer. लेकिन वो
Can
क्यों
it
होती है?
also be कि वो orbital जो electrons होते हैं, they lie in like 3D and 4s और उनके बीच में इतना like difference नहीं होता, तो इसलिए they can like readily like form more ions.
Of course, we can definitely say that. बिकॉज उनमें इतना एनर्जी का डिफरेंस नहीं होता, तो वो एक में से लूज करे या दूसरे में से लूज करे, कोई बहुत ज्यादा फर्क नहीं पड़ता, तो वो दोनों पे स्टेबल हो जाता है. So yeah, we can definitely say that. Okay, sketch the shape of a 3D XY orbital. So XY means it is between the X and Y axis. So it's going to be here, 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 and here. Okay. Explain why they form colored compounds. We have already talked about it, that they have ligands. No, we did not do this today. वो मैं कल किया था. So we'll say that ligands can cause D splitting. ठीक है. Or electrons can be excited by absorbing specific, absorbing frequency corresponding to energy gap. Okay. So complementary color is seen. Okay. Those are the 3 points through which we can clearly see कि वो colors क्यों देते हैं. Okay. Color of copper hydroxide solid. The color is light blue because we have seen it multiple times. And when you add it to ammonia and there's a ligand exchange process, it goes to dark blue.
Sir,
Yes.
there was this question I was doing. इसके अंदर वो जब अमोनिया आ रहा था तो like it was like completely like substituted, तो वो NH3 6 हो गया था. Is that like a possibility या फिर like सिर्फ specific like transition metals के साथ हो सकता है?
देखो, वो हो सकता है, और लिगेंड्स का हम जो पढ़ते हैं, हम ट्रांजिशन मेटल्स के साथ ही उसको देख रहे हैं. 6 को वो करता है, लेकिन द पॉइंट इज, डज इट स्टे देयर? डू द अदर अमोनिया रिपेल इट एंड ड्राइव इट अवे?
तो like how would I know कि like मैंने 6 करने के like मैं सिर्फ 4 करूं?
Sorry, I got disconnected. Okay, use Le Chatelier's principle to explain why precipitate is formed when sodium hydroxide is added dropwise to copper hexaaqua. Let's see. When you add hydroxide, you are increasing the concentration of this ion. And when this increases, equilibrium shifts to the right. So a solid is made. And that is what we'll say. We'll say that adding NaOH increases the concentration of OH minus and equilibrium shifts to right, forming precipitate. Okay. There are 2 possible stereoisomers with the formula. ठीक है. Draw 3-dimensional arrows. अच्छा, अब stereoisomers में you have to understand that you need different ligands in the same plane. अगर same ligands in the same plane आ जाएंगे ना चारों, तो फिर मुश्किल हो जाएगा इनका stereoisomerism बनाना. So I have 4 ammonia. If I put all of them here, then I will not be able to get the stereoisomers. So I should move them. Let's say मैं इसको ऐसे move कर देता हूँ. ठीक है, कर तो हम सकते हैं. एंड इसको हम वाटर के साथ रिएक्ट करा देते हैं. ठीक है, एक ये पॉसिबिलिटी है. दिस इज सिस. ठीक है, और द अदर पॉसिबिलिटी इज ट्रांस. क्लियर? सो वन इज सिस, वन इज ट्रांस. ओके. electrolysis, redox, equilibria. Okay. A solution is made by dissolving copper sulfate in an excess of ammonia. The solution contains a copper complex. This write an expression for case tab of this. Easy. We have the ion that is made, the complex copper 4 ammonia 2 plus its concentration. Don't forget to put the square brackets twice. Divided by, I will have 4 ammonia. So the power 4. And I have the octahedral complex for this. So copper sulfate to nahi hoga, copper with 6 water hoga, 2 plus hoga, and uski concentration. State the color of the solution with ammonia displaced it, that is dark blue. Okay. The solution of this is heated gently in a fume covered so the ammonia is released. A precipitate of CH2 formed. Okay. A sample of copper hydroxide is added to concentrate HCl and reaction takes place forming a colored complex Y. So obviously the chloride is going to come and displace OH2. Okay? Yeah, even ammonia. A sample of this is added to sulfuric acid. The reaction takes place forming a colored complex. Suggest an equation for the reaction of copper with 4 ammonia to form copper hydroxide as the aqueous solution of copper. So when we heat it, we should get copper hydroxide. So we take this thing, copper with 4 ammonia. So the hydroxide is definitely coming from water. So this is going to give me copper hydroxide and ammonia. Okay. But that's not all. Water is also breaking down to give me H positive. So I have 2 of water, so 2 of this. And there you go. Now I can just balance it out. So I have 4 of this. Make sense?
So where did we get H plus from?
So we got OH2 because water broke down. So if water is giving hydroxide, it should also produce H positive. Suggest an equation for the reaction of this with constant hydrochloric acid. So with hydrochloric acid, we have this with hydrochloric acid, obviously ions honge. And they're going to make this copper with 4 chloride wala ligand. And water. So I need 2 of this to make 2 water because 2 hydroxide and I need 4 of this. Okay, done. Okay. You might argue कि वो बाकी H positive कहाँ गए? वो पड़े रहेंगे. The solution will go more acidic. You're adding acid. So what?
Sir, can we write 4HCl instead of just Cl minus?
We can, yeah. You can certainly. But उसमें फिर पता क्या होगा? If I write this, let's try it out. 4HCl. So I will get CuCl4 with 2 negative, but then I also have water made. 2 hydroxide and 2 water बनेगा और 2 H positive मेरे पास extra बच जाएंगे. But that's fine. No problem there. Okay, complete the table with the color and geometry of complex Y and the color geometry and formula of complex Z. Okay, complex Y is copper with 4 chloride, so that is going to be yellow. And it is tetrahedral. Okay, we have already written the formula. And color of Z kya hai? dilute sulfuric acid. अब sulfate तो नहीं बनाता तो definitely water ही होगा. So copper hydroxide will form blue precipitate. या blue precipitate से वो light blue solution बना है. ठीक है. And geometry is going to be octahedral. And you're going to basically get copper with 6 water plus 2. Explain why complexes Y and Z are colored and why the colors are different. Again, we'll talk about first of all why they're colored, because the d orbitals, there's a dd splitting because of these ligands, and there's a gap in energy and light is absorbed to uh, because the electrons are excited depending on the energy gap, and because the energy gap is different for different ligands, we see different frequencies absorbed, so the colors are different. Clear?
Sir, I sent you
Yes.
like this one part, like WhatsApp. Could you like check that?
Sure.
Thank you.
Okay, so the question says that we have cobalt, hexaaqua cobalt, 2, and we add ammonia in excess. Okay. So when we do this, again, ammonia is going to displace, I think, 4 of them. So you will get cobalt with 4 ammonia, and there will be 2 water left over. And that is all neutral, plus 4 water molecules that are pushed out.
Sir, I did the same thing, right? Of your marking scheme, it's like 6 ammonia are there.
6 ammonia are there.
Yeah.
Cobalt किस period में? Let me see. Cobalt is before copper. Cobalt का size बड़ा है. So it is possible कि cobalt इन सारों को accommodate कर ले. But this is something you just have to memorize. There are 6 in your syllabus that you just have to memorize. ठीक है?
So वो कौन
I
से
think
हैं?
मैंने आपको उसकी लिस्ट भेजी थी.
You
Yup.
sent the colors वाले यार.
हाँ, तो उसमें वो सारे ligands हैं ना.
Okay.
अमोनिया के साथ इसका कलर ब्राउन होता है.
तो basically हम याद करें कि cobalt हमेशा like 6 ammonia लेगा.
Cobalt, because it's a bigger ion, relatively bigger ion, बहुत ज़्यादा फर्क नहीं है size का, but it is able to accommodate all 6 ammonia, but copper is not.
ठीक है. Got it.
Define the term monodentate ligand, a ligand that forms only one dative bond or that donates one lone pair to make a dative bond. Okay, to the metal ion. Okay, give the formula of P including its charge. P is what? So this is monodentate ligand and this is the ion that they're bonding with. So you have 2 of these coming in. So you will get Ag with S2O3, 2 of them. And the overall charge is going to be what? -4 + 1 -3. When 1 mole per dm cube NaCN is important because it will give us cyanide, and cyanide is a much stronger ligand than anything else we have seen. Okay. Is added to a solution of P, a mixture which includes a second linear complex is formed. Okay, cyanide ne displace kiya hoga. In this mixture, the concentration of Q is much greater than the concentration of P. Q kya hai? Achha, the Q, that's one. So because the concentration is much greater, that shows the equilibrium is more towards the right. So Cn minus is going to displace it. So we're going to get this. And this is going to be displaced by Cn minus, 2 of them. Why 2? Because it's a linear complex. Okay. So we'll get AgCN, 2 of them. And that's going to be just -1. Plus both of them pushed out. So that's the reason why concentration is much greater than the concentration of P. So we can say that this has a greater K stab value than the previous one. yeah, this ligand is stronger and makes more stable complex. Don't just say that ligand is more stronger. Just talk about the complex somehow. So you can say the ligand is stronger and forms a more stable complex, or you say that the K stab is higher in this case. The type of reaction ligand exchange process. Okay. Platinum forms a complex ion with the formula this. In this complex ion, the carbon atoms bond to the platinum. ठीक है. Stereoisomerism है. You have 4 ligands, so ये cis trans isomerism करेंगे. Cis trans होगा ना. So we can do chloride, chloride, CN, CN, and we can do chloride, chloride, CN, CN. Okay. The shape is square planar. The type is cis trans or geometric electrochemistry. Okay, this is not relevant. All right, so we are done with this.